Robot hearing as a sort of area has made really quite a lot of progress over the last few years. But within that, it faces challenges that are very different from robot and computer vision. So sound itself is a very challenging modality to handle. There's interference from different sound sources in the scene. These sound sources actually impinge on the microphone at the same time. So what we record at a single mic is the mixture of all the different sound events within the environment. And disentangling that mixture is a really difficult task. Now, the human brain itself is actually amazingly capable of making sense of these complex acoustic scenes. There has been a lot of work that actually builds on deep learning to make machines hear better. The sort of challenge that we're facing, though, within robotics is that these models typically rely on very big data sets and architectures, so model architectures that have a big compute footprint. But robots have very limited power and compute, and they need to make decisions in near real time or in real time. So much of my current work is focusing on embedding actually our knowledge about the human auditory process directly into these architectures of models that are driven by deep learning. And the underlying hypothesis here is that by building the right structure or architecture into the model, we can make these models much more efficient, much more adaptable, and much less dependent on huge data sets.